Everyone, thank you, Christian, for actually letting me give the presentation this afternoon. I'm going to give you a very quick demonstration of our PM200 system, which has been developed using our CVM technology, comparative vacuum monitoring technology, for a hotspot monitoring. We've been working in association with the major aircraft manufacturers and air forces around the world to be able to get this technology fielded. We now have a system which enables us to monitor sensors which are installed permanently on the aircraft. So I'm going to give you a quick demonstration of how we actually use the system. The first, if you just zoom in on the screen down here, the first thing we need to do first is select the operator, and I can do that using this button here, so I'm selecting mine now. So the next thing it's asking me to do is plug the connector into the system which we installed in the aircraft. So on the aircraft we will have a CVM sensor, which you can do in a variety of different shapes and sizes. We can do a sensor which looks like Australia. We can do a sensor which looks like any part of your aircraft. So it's very flexible in terms of the way that we can do the sensor designs. All the systems have been designed to be airworthy, so we've got an airworthy standard connector. All the products and all the systems are basically aircraft standard materials. So having now connected the PM200 to the connector which will be installed on the aircraft, the connection can be up to 10 meters away. I'm now going to press the go button. Okay, from this point onwards, the whole system is completely hands-off and automatic. And it's just going to give me one bit of information at the end, whether or not we've got a crack under the sensor. So all the data processing, which is a log, is effectively we're just using pressure transducer signals to detect whether there's a flow of air between a gallery which is at atmospheric pressure and a gallery which is at a partial vacuum. We have a number of stages that we have to go through to actually be able to do this. So the first two tests are continuity checks. So we check effectively by pulling air through the sensor. Sorry, can you just go with can you just put just your camera on the screen there? If you can see it. Oh, it's not working. Okay. Anyway, so you'll have to believe me, there is a high flow number at the moment, which is indicating that we have a high flow rate. So essentially we've opened a valve, we've got a vacuum pump and a vacuum chamber in the PM200 unit, and now what we're doing is effectively sucking air through the galleries to make sure there aren't any blockages. One of the failure modes that we can have with our sensors is if one of our technicians come and stuck his boot on the system or caused a blockage. So we want to make sure there aren't any blockages in the circuit, so effectively pulling air through the three channels. We have three channels. We have the ambient pressure, we have the sensing vacuum gallery, and we have a third gallery which is a compensation gallery. And we use the compensation gallery to effectively null out any changes in temperature or pressure which could affect the effectively noise into the system. The system itself does that nulling process, and the next thing it's doing at the moment is it's actually doing the CVM check. You can see on the screen at the moment that the information about the phase is here, the test number is here, we've got some progress bars telling you how quickly we're going through the process. At the moment we have two sets of flow restrictors in the PM200 which are being bypassed to effectively establish a vacuum within the compensation channel and the sensing channel. And in a second, once it's completed that bypass operation, you've established an equilibrium vacuum. It will then put the flow units back into to monitor the flows, and then we'll effectively be monitoring the difference in the flow rate of air into the sensing gallery versus the monitoring of the flow rate to the compensation. And because the compensation is actually sealed within the sensor itself, it's part of the integral sensor design, we are able to effectively look at just the flow rate into the sensing gallery, but any extraneous noises that you see both in the compensation gallery and the sensing gallery are nulled out. So if you had this plugged into the other side, you would see this figure here around about zero. Zero flow, or zero flow into the vacuum, into the sensing gallery. So anything above 2 indicates that we've got a crack. So we might expect to go and see a baseline around about anywhere between minus 0.5 to plus 0.5, depending on some permeability circuits. Quite difficult to balance them out, but we set a 1:3 signal-to-noise ratio. So we're effectively placing the hurdle for what indicates a crack 2 times above the noise floor. So as you can see, we're now in the last phase, which is doing a continuity check. So continuity through gallery 2. So at the moment, we've got a high flow reading, because that's effectively what you expect to go and see through an unblocked gallery open to atmosphere. So the process is almost over. We've got a little bar up here which tells you how many seconds. So that's the clock. And now it's basically telling you that you've exceeded the limit for your gallery 1. So if I go to here and press the details, you can see that we've got the 3 continuity readings, which are stored, and the CVM reading, which is 15.4, and that's above the limit of 2. So that now indicates that you've got a crack under your sensor. So this actually, if I can just quickly show you the item we've got here. This is actually a real piece of aircraft structure. Many of you have flown on MD-80s. This is what's holding the rear pressure bulkhead on. To actually do this inspection, they're having to remove the galleys and toilets to be able to do a high-frequency eddy current inspection. So we developed a sensor which covers the area around which you do the high-frequency eddy current inspection. You can connect a number of sensors together in series, and then effectively you connect onto those, plug it in, take a reading. You don't have to remove the galleys and the toilets. You can do the check in 5 minutes, as we've seen, and life is sweet.
Thank you, Mark. There's plenty of opportunities to see that one still out in the booth. We come to the last but not the least.